Let's discuss solve problem 1 on doubly linked list. Consider implementation of unsorted doubly linked list. Suppose it has its representation with a head pointer and a tail pointer. Given the representation, which of the following operation can be implemented in big O of one time? That is constant time. These are the operations available in front of you and the options are also available. You need to identify the correct option. I would encourage you to pause the video for a while and try to answer this question on your own. I hope you're done. Okay, let's move on to the solution. Let's consider the first option, that is insertion at the front of the linked list. Please note that we are talking about an unsorted doubly linked list which has a head pointer and a tail pointer. Okay, so we have two pointers, head pointer and tail pointer. One pointer, that is head pointer, is pointing to the first node of the list and tail pointer is pointing to the last node of the list. So this must be noted. Let's consider this operation, that is insertion at the front of the linked list. You know, it is very simple operation, right? We have a head pointer pointing to the first node of the list. We can easily add a new node at the beginning of this list. This is very easy. First, we will create the new node. You can see over here temp pointer is declared, and using malloc function we are allocating memory for this node. Apart from this, we are allocating null to prev part, data to data part, and null to the next part. That is what you can see as a result. A new node has been created and temp pointer is pointing to this node. Okay. After this, we are updating the next part of this node so that it can point to this node, right? And we are also updating the prev part of this node so that it can point to this node. And after this, we will simply update the head pointer so that it can point to this node. As simple as that. This whole operation, that means insertion at the front of the linked list, will take constant amount of time. Isn't that so? There is no loop involved. Thus, we can say that operation 1, that is insertion at the front of the linked list, takes constant time. Let's discuss insertion at the end of the linked list now. Insertion at the end of the linked list is also very easy because we have a tail pointer pointing to the last node of the list. Now we just have to update the next part of this node and the prev part of this node. For this purpose, we will put this line of code, that is tail next is equal to temp. That means we will update the next part of this node. And then we will update the prev part of this node so that it can point to this node. Now you can see there are two lines of codes, right? Obviously, this will take constant amount of time. So insertion at the end of the linked list takes constant time. Let's discuss deletion of the front node of the linked list now. This is also very easy operation. Here we want to delete the first node of the linked list. For this purpose, we need a temp pointer which must point to the first node of the list. After this, we will move our head pointer towards right by using this line of code. And then finally, we can use temp pointer to delete this node. We will put this in free function. This will delete this node and that's it. This will take constant time, right? So deletion of the front node of the linked list takes constant time. Now let's see how much time deletion of the last node of the linked list will take. If we want to delete the last node of the linked list, we need a temp pointer for this purpose that must point to the last node. We can do this by using this line of code, temp equals to tail. There is no need of any traversal because we already have a pointer pointing to the last node, right? We just need a temporary pointer so that it can point to this node and we can delete this node using this pointer. And now we need to move our tail pointer towards left so that it can point to this node. For this purpose, we need this line of code, that is tail equals to tail prev. In this way, the tail will point to the second last node of the list. Let me tell you, in case of singly linked list, we need to traverse the list. But here, there is no need because this is a doubly linked list. We can always go to the second last node from the last node, right? Now, we just have to free this node. That means we have to delete this node using free function. Finally, we will update the next part of this node and this temp pointer using these two lines of code. This whole piece of code will take constant time. Isn't that so? There is no loop involved. Again, this operation takes constant time. So, option D is definitely the correct option.